Good evening, everyone. Welcome to day 7 of our 15 days free training program on Python for AI. Before we move on to day 7, let's quickly recap what we learned till now. So, till now, we've completed the data types such as fundamental category data types, sequence category data types, list category data types. So in fundamental category data types, there are int. So int stores whole numbers and it will not store any decimal point numbers. And we have float here, which will store the decimal or real numbers, which has floating points, and it will store real constant numbers. And then we have Boolean. It stores true or false values. And then we have the complex data type. So it has a real plus imaginary part. And for example, 2 plus 3j, here 2 is the real part and 3 is the imaginary part. And j refers to under root of -1. So that's complex data type. And then we've also learned about sequence category data types. So these are used to store ordered collection of values or to store sequence of characters. So in sequence category data types, we have string, bytes, byte array, and range. And then we've also learned about list category data types. So these are used to store multiple values. So lists and tuple are used to store multiple values. So that values can be of same data type or different data type, or it can be both. And list also allows unique values and duplicate values. So list is used to represent with square brackets and tuple is used with parentheses. So in this way you can represent list and tuple. So the main difference here is list is mutable and tuple is immutable. Immutable means you can modify the elements in the list once it's created also, and in tuple you cannot modify the elements. But if any tuple has mutable elements like list, let's say we have a tuple and inside of that we have a list. So the contents of this list you can modify. So if you have a mutable data type inside of a list which is immutable, you can only modify the inner contents of this mutable data type. You cannot mute or modify the values, the other values, and you cannot replace this list also. Only you can modify the values inside of this list. So till now we've learned these three data types in Python, and we have worked with tuple and list in the last class. So now let me ask you something. So list and tuple, they work with unique values and duplicate values, and also they have ordered set. So it will maintain insertion order, that is in which order we will insert, in that order they will be displayed. But in real world data, do we always want duplicates? No, right? Sometimes if you want to build a database of, let's say, registered email IDs or unique user IDs or MAC addresses or your roll numbers, college roll numbers, or your Aadhaar numbers, let's say. So these values are all unique values. So they don't, two persons don't have the same ones, right? So we work with databases which have unique values also in real time. So that is why we have sets. So sometimes we don't care about the position. So in which position the value is, or we don't care about the indexing, or we also don't care about the order. So we only care about one thing, that is having unique values. So in that case, we have the set category data types. So these set category data types are used to store multiple values. So you can store multiple values either of the same type. So you can have 2, 3 int values or different type. You can also have int value and then float value and then other string value. Or you can also have both types. So same types, different types. It can be anything, and it will only store unique values. So there are two data types in string set category, that is sets and frozen sets. Firstly, let's learn about sets. So set is a predefined class and it is treated as set category data type. So this set is used to store multiple values either of same type, different type, both types, and also with unique values. So major rule is here, it does not allow duplicates. So that is the biggest difference from list. So list and tuple will allow unique values and duplicates, right? But here set won't allow duplicate values. So that is the difference from list. So here sets are used to define by the curly braces. So if you want to give or mention any set, you should give curly braces and you should separate the elements using commas. And then our set won't maintain the insertion order. So insertion order is nothing but in which order we are inserting our elements, in that order it is producing in the output. So this is because set objects elements can be displayed in any of the possibilities. So the elements can be shuffled or it will give some order, but it will not maintain the insertion order. So if I write, let's say s equals to 10, 5, 20, and I'll print s. That is my set, okay? So here the output order may change. Output can be like 5, 20, 10, or 20, 10, 5. It can be anything. So in the same order I've inserted the elements. In that order itself we won't be getting in the output. So that is how set does not maintain insertion order. This is because it will internally implemented using hashing. So it uses hashing method. That is why it does not maintain the insertion order. We will learn about the hashing in detail. So can we do indexing in set? No, we cannot do indexing in set because indexing requires order, right? So indexing is nothing but giving values from 0 to till length minus 1. So indexing requires order like 0, 1, 2, 3, 4. So 0 belongs to some element and 1 for some element. So we need the order to give the indexing. But set does not maintain order. So that is why our sets won't have indexing. So it does not support the indexing operation and it also does not support slicing operation because we don't have the indexing, right, due to no order. That is why it does not support indexing and also it does not support slicing. And here set is of a mutable type. So mutable means we can modify the original element or the object. So here in set we can add or remove elements. So it is mutable based on adding and removing elements. So let's say s equals to 1 comma 2 I have in my set. Now I'll add some element 3. Now s will become 1 comma 2 comma 3. In the same way I can also remove elements. So that is how it is mutable. But if you want to perform, let's say s equals to or s of 0 equals to 10. This is the item assignment. This is called item assignment. So this you cannot do. This operation you cannot do because indexing won't exist in set, right? As it does not maintain the insertion order, indexing also won't be happening. So that is why you cannot be giving item assignment in a set, because 0 doesn't represent only single element in sets, right? So that is how item assignment won't be happening in set. And there are two type of set objects. They are empty set, non-empty set. So empty set is the one which does not contain any elements. So empty set means obviously it does not contain any elements, and the size of set will be 0, or the length will be 0. And then non-empty set means it will contain elements and the size will be greater than 0. So here, as we know, set is represented using curly braces, right? But let's say I have given s equals to curly braces and I want to create an empty set, let's say. So you may think this is empty set, right? Because it does not contain elements and it is represented with curly braces. But this is not an empty set, and this is an empty dictionary. So initially it is considered as an empty dictionary only. But if you give elements like 1, comma 2, comma 3 in this curly braces, this will be considered as set. But without any elements, it is considered as empty dictionary and not empty set. So if you want to create an empty set, what you have to do is you have to be giving s equals to s set function. So if you use this set parenthesis, that is a set function, then this is considered as an empty set. So whenever you want to create an empty set, you should only be using this set function. So this is very important for exams, so please remember. And if you want to create some non-empty set, obviously you can use curly braces and you can give the elements you want in the set. Now let's learn how sets work internally. So in a set, there is something called as hashing. So hashing is the process of converting an object into a fixed sized integer value called as hash value. So using hash function, we'll be doing that. So first, before understanding this, let me ask you something. So when you search for your locker, suppose if you have some locker area in your college and if you want to search for your locker, so do you check every locker one by one? Will you check the first locker and if you'll check that is yours or not, and then you'll go to second locker, check it, and then you'll go to third locker? You won't do that, right? You'll directly have some number for your locker and you will go directly to your locker number. So that is how it works. So the locker number here is like the hash value. So as one person has assigned locker number, one object also will have some hash value. So using that hash value, you can locate to that location and you'll achieve or get that object or the content it has. So hashing means it is a process of converting an object into fixed size object. So let's say you have an object, I'll say, let's say 20. So this int number is my object. So what they'll do is they'll convert this into a fixed sized integer. So how will they convert is they will do the hash value of 20. So using the hash function, they'll get the hash value 20. And in that value, let's say A is the hash value, just the placeholder. Hash of 20 is A. So in this location, they will store this object, which consists of 20 value. So that is how sets work. So Python will not store your numbers randomly in the sets. Python won't store the elements or objects randomly. So it will calculate a hash value of your objects using the hash function, and then that number will decide where it will be stored internally. So in that value location, the object will be stored. So moving on, the sets, why do they use hashing? So sets are implemented using hash tables. So same like our database tables, there will be hash tables, and elements are stored based on their hash value. As we have learned, there will be hash function. So the element value will be calculated using the hash value, like hash of the element will be calculating, and based on the result, there it will be stored. Suppose, let's say this location is here. In this location only, your element will be stored in the hash table. So this does is it will enable very fast lookup. That is O of 1 time complexity average time. So let's say I'm taking 10 in S. So this in is like a membership operator. What membership operator does is it will check whether your 10 value is in your set S or not. So what it will calculate is it will check if your element is in this set. In this case, it will check the element is in the set or not. So let's say S is 9, 10, 11. Okay. So 10 in S means what it will do internally means it will not scan the entire set like a list. So in list what they'll do is let's say we have the same elements 10, 11. So if I want to check if 10 is in list 1, what happens is firstly it will check 9. So 10 and 9, if it is same, it will check, and then it will move on and it will check all the elements in list. So Python will check the elements one by one from beginning to ending. It will check one by one element until it finds the element. So 10 is the element I want, right? So first it will check 9. So 9 is not 10. Then it will move on from beginning to end and it will check 10. So it found 10. So in that way, it will check all elements until it finds the element. So this is the linear search. So this is called linear search, checking all the elements from beginning to ending. That is called linear search. So here, time complexity. So time complexity is nothing but how much time it is taking to get some element. So here time complexity is O of n. So which means if your list has, let's say 10 elements, if your list has 10 elements, it will do 10 checks. For sure, it will do 10 checks. If your list has 10,000 elements, your checking will also be happening 10,000 times. So what happens is the performance grows linearly with size. So it will take more time. If you have less elements, it will take that much of time. If you have more elements, it will take more time. So if you have 10,000 elements, the time complexity will be 10,000. So it will take more time in case of list. As it will check each and every element, it will take more time. But in a set, so I want to check 10 in S. So let's say 10 has, so the S set will have 9, 10, 11, let's say. I want to check 10 in S. That is if the element 10 is present in your S list or not. So what happens internally is it will not scan each and every element like a list. It will instead do the hash of 10. So it will convert, like get the hash value of the element 10, and after getting that hash value, it will use that hash value to determine the correct bucket, like the correct location. So based on this hash value, it will check or get the correct bucket or location, and it will check directly that location only. Instead of checking all the locations, it will directly check that location such that your time complexity will be 1. That is, it means constant time. So here what it means is the lookup time or the time complexity does not grow with this size of the set. So time complexity of a set is O of 1. This is because if I have 10 elements also, it will take the, let's say, time A. It will take some time. And if I have 10,000 elements also, it will take the same time to get my element, to check it. Okay, so it usually takes the same amount of time, whether the set will have 10 elements or 10,000 elements also. So that is why the time complexity or the lookup time of set is O of 1. So that is why sets are very fast, and these are used in membership testings. Membership testing is nothing but what we have done here. So 10 in S means here we are using it membership operator. So this is membership testing. It is checking whether 10 is in S set or not. So why does sets don't have indexing? So that is because sets do not maintain insertion order and elements are stored based on the hash values. So it will check the hash value using the hash function and it will directly store any value in that exact location. So that is why sets won't use order. They mostly rely on the hash values rather than storing it based on the order. And that is why indexing and slicing are not supported. So one important rule is that only immutable objects are stored in sets. Immutable objects are only hashable values. So immutable objects means you cannot modify them, right? Immutable objects are not modifiable. So only immutable objects are hashable objects and only you can store these values in set. You cannot store mutable objects like list, one more set or dictionary. You cannot store mutable objects because mutable means it is modifiable, right? So you can modify the values. But in a set, what happens is if you have some element, you are storing some element in a set, what they'll do, they'll calculate the hash value. And then based on that hash value only, they'll store. But if I store some mutable object like list in my set, so let's say I am storing some list in my set. So initially it had 1 comma 2, let's say. So what they'll do is they'll calculate the hash value of 1 and 2 and they'll take the combination. Somehow they'll get the inner combination and they'll store these values of this set in that location. But as it is mutable, if I change 10, so 1 as, let's say 10 I've changed. So what happens here is the hash value also will change, right? So the value of list 1 comma 2's hash value is different from the hash value of 10 comma 2. So hash value will change. Then what will happen is your Python wouldn't know where it is stored. So the stored location, it wouldn't know if we change the value. So that is why there will be chaos and it will be messy. So that is the reason we cannot store mutable objects like list, set and dictionary inside of another set. But you can store the values like int, float, string, tuple. So these are immutable objects, right? So you can store these. So they cannot be modified. That is why hash value won't change. So that is why you can store only these and you can also store frozen set because this is also immutable. So here as I wrote tuple if elements are immutable. So basically tuple is immutable only. But if a tuple consists of mutable objects like list, you can change values inside of that list, right? So if a tuple doesn't have any elements which are mutable, if it contains only elements which are immutable, then you can store that tuple inside of a set also. So sets only can consist of immutable objects because their hash values won't change. You cannot store mutable objects like list, set, dictionary because their hash values will change and Python will not know where your original element or the exact element is stored in your memory space. So that is the reason. So sets are unordered and they don't maintain an insertion order because they are hash based. So hashing is an important topic when it comes to sets. You don't need to know how each element is hashed, okay? Just you need to understand the whole concept of hashing. So once you understand hashing, sets will become very logical and you will understand them in a better way. Now let's move on to the coding part. So here, as we got to know, if I want to create some empty set, you cannot just use these curly braces because I have given a equal to curly braces with no elements, right? So I try to find the data type of a using the type function. Inside of parenthesis of type function, I am giving a and I'm printing that whole thing using print function parenthesis, right? So if I do that, the empty curly braces are treated as dictionary data type only. So if you want to actually create an empty set, you should use the set function here. So what you can use is you can give some variable equal to set. So then this variable will be an empty set. So the data type will be set itself and not dictionary. So if you see I'm running c equal to set, so I'm assigning an empty set to this variable c. And I'm printing the type or the data type of c using the type function. So if you see here, this is a set. And if I check, so as you can see, this length of C that is a set is 0. So this is an empty set. And then we have the non-empty set. So I have taken the set of 1, comma 2, comma 3 and I have assigned it to the variable B using this assignment operator. So this is a non-empty set. Let's run it. So here, as you can see, we have run this and the type of B. So the data type of B is set data type. And then moving on. So I'm assigning A equals to the curly braces 10, 20, 30, 40, 10, 20, 30, 40. So as you know, set won't allow us duplicates, right? But if I give duplicates, what internally happens is, as you can see here, it will only give my unique values in that set. So the other duplicate values won't be considered and only it will produce me the unique values in the set. So that is how internally sets will ignore the duplicates and only will give me the unique values. Even if I give it hard coded, it will give me only the unique values. So here we have the elements 10, rosum, which is a string, and then float, and then one more string, and we have a boolean value of true, and one more string, which is a Python. So as you can see, we have duplicates here. So what will happen here? So these are all of different data types, right? So here also, as you can see, only the unique values are considered in a set. So the second Python you cannot see anywhere, right? So only one Python is considered. So here I'm trying to do indexing, but set object, as you can see, we got a type error. Set object is not scriptable. So this is because set won't maintain the insertion order. So that is why indexing is not possible. And That is why you cannot give item assignment also. So here, this is indexing. So I'm trying to index, that is get the element at the position 0 in a set B. So that is not possible because set won't maintain insertion order. And it's same with the slicing. So here you can see the beginning index is 0 and ending index is 4. So I want to get elements from 0 to 4, that is 0, 1, 2, 3. But as indexing does not work in set, as it won't maintain the insertion order, in this slicing also won't be happening, and will get a error. And here I'm trying to reverse the string using the slicing syntax, which is begin colon end colon -1, which is the step value. So if you've seen the previous classes, so that is the syntax. Begin is to set, ending index is to step value, and this exact value is to get the reversal of any object or elements. So here I'm trying to do that. So this comes under slicing as well, and we cannot do slicing because there is no maintaining the insertion order. Here I'm trying to do the item assignment. So at the place of 0, I want to replace the element. So here 0 is 10, right? So in place of 10, I want to put 100. But this is also not possible because this 0 index does not point exactly to 10 only, because it doesn't maintain insertion order. And then moving on, here we have a new set, and this is stored at the location. Using id function, I can get the location of my set. And then for this, I want to add an element to the set object. That is neut string I want to add to this set object. So I can use a function called as add parenthesis. And using this, I'm trying to add it. So as you can see, this neut is added at the to this B set. But if you see, there is no order here. So it does not maintain the same order. It just randomly produces me the order. And then moving on. So as you can see, the B value has the same location, memory location. And when we add elements in that same location only, that set is modified. So that is how we'll be getting the values. So I've told about the hashing mechanism, right? So we can get the hash value of this string right here. So what happens is they'll take each character's hash value, and then they'll get a combination out of it. And this is the hash value of string neut. And this neut will be stored in this location inside of the hash table. Okay, so that is how they'll get these values easily. And the storing also will happen in the same value. They'll get the hash value of that element, and in that location they'll store your element, such that the time complexity or the lookup time will be less. Easily they'll get by checking that exact location. You can also perform hash values of float values. So here, if you see integer values, so basically hashing means we'll convert an object into fixed integer data type, right? So directly 10, it is already in our integer type. So that is why it is 10 only. But if you see here, we have characters in the string. So they'll get the ASCII values and they'll get the combination of values. So that's how we'll get this long value for a string. In the floating point also the same thing. They'll be doing internal calculations and they'll get a value, which is the hash value of this. And when you go to the hash of true also, so as you know, this true value, basically it represents 1, right? And false is 0. So it is already consists of integer value, right? So that is why the hash of true is 1. And then there's one more topic in the sets. You can generate a set using a topic called as set comprehension. So here I am trying to find the square of numbers from 1 to 5, let's say. So what you'll do is you will be giving the set object name equals to So the elements which consists in this set object, first we need to give that. So as you can see here, I have given x asterisk x. So x asterisk x means x into x, which is x square, right? So the x square value, where the condition here is for x in range 1 comma 6. So your x values will come from this iterable object, which is range, that is 1 comma 6. So 1 is the beginning value and 6 is the ending value, and the elements in this range 1 comma 6 is 1 2 3 4 5, and this 6 will be excluded, so you'll only get till 5. So 1 to 5 values. So your x value, first it will point to 1. So this condition it will check and it will point first x is 1, and then it will get our element. So we want x square, right? So 1 into 1 is 1. So this one will be added into your set object. So 1. And then x will point to 2. And then x will be 2, right? Based on this for x in range. So x is 2. Then we will calculate x square value. So x square, 2 square is 4. In the same way, it will calculate when x is 3, 4, 5. So when x is 3, the x square value will be 9, right? So these values will be added into your list, sorry, set 1, comma 4, comma 9. And when your x is 4, x square will be 16. And this 16 will be in your set object. And then x equals to 5, x square equals to 25. And that will be your set object. So in this way, I can generate a set also using this set comprehension topic. So when I print S here, so what happens is, so as you can see here, we will get all the values we predicted. So in a range 1 comma 6, that is 1 2 3 4 5, you will be adding x into x, that is x square values, to your set S. So when you print S, so all the square numbers in that range 1 comma 6 will be added here. So that is 1 4 9 16 and 25. And here, moving on, we have some predefined functions in a set. So these are used to modify a set. So firstly, we have add function. So this function is used for adding elements to set. So you can use this by the syntax, the set name. So you need to give the set name dot add, and which element you want to add, you can give inside of this parenthesis. So here we have a set S1 equals to 10 comma 20. So if I print S1, so my set is 10 comma 20, and if I print, sorry, S1. So for print, we need to give giving parenthesis. So S1 is 10 comma 20. Now I want to add S1 dot add Python. So I'm adding the string Python to my set S1. So this will be added to S1. And also next I'm trying to add one more string, that is Java. So this also will be added into the set. So if I run these both and I'll print S1. So as you can see, 10, 20, Java, Python. So in this way, the values are added. If I can also print S1 using just S1. So if you see here, S1 consists of 10, 20, Java and Python. And then we have one more feature to remove elements in a set. So clear function is used to remove all the elements of a set. You can use this with a syntax, that is set, the set name you should be giving, and dot clear you should be doing. So here I have a set B which consists of elements 10, ROSM 23.45, Python, true, and Python. So internally, these duplicates values will be considered into unique only. That is, only one Python will be considered. And now, if I want to clear all these objects, what I can do is I can use b dot clear parenthesis. So this will clear all the elements in your set. So let me just run it. So B consists of true, ROSM, Python 23.45 and 10. So I want to clear all elements. So what I'll do, I'll be using clear function. Then there will be only empty set. So as you know, only this curly braces won't mean empty set, right? So that is why to represent empty set, they'll be using set. So this, after clearing all the elements, this is an empty set. So that is the representation here. And then there is one more function called as remove function. So this is used to remove elements from a set object. So if that element does not exist in your set, then we will get a key error. So how you can use this is, you'll just write the set name dot remove element. Which element you want to remove from that set, you will be giving that in place of this, inside of the parenthesis of the remove function. So now I have a set which is 10 ROSM 23.45 Python, true Python. And if I print it, so I have 5 unique elements in this B set, and I want to remove the ROSM value. So what I'll do is I'll give dot remove. So B dot remove the function, and inside of that I'll be giving the element name which is ROSM. So if I do that, as you can see, the value ROSM before it is there in our B set. Now it is removed. And now I'm trying to remove Python. So as you can see, originally Python is in our B set. Now we don't have any value which is Python. Only we have true 23.45 and 10 only. Now the set we have is this, right? True 23.45 and 10. Now if I try to remove ROSM again, so it is not present in our set, right? So if I try to remove that, we'll get a key error because ROSM string is not present in your current updated set. And then if I try to remove a value which is 100, let's say, but 100 is not present in your set. We only have 3 elements and 100 is not one of them. So if I try to remove 100 from this set B, we'll get a key error because it is not presented in the set. And then we have a function called as discard. So this function, it is used to remove an element from the set object. So to remove elements also, you can use discard function also. But what is the difference between remove function and discard function means? If element is not present in remove, we will get a key error, right? But in discard, if the element doesn't exist, we will not get any error. So how you can use discard is you will use dot discard the element name. So the set name dot discard the, in the parenthesis you should give the element which you want to discard. So initially my B set is 10 ROSM 23.45 Python, true Python. So if I print, I have 5 unique elements here, that is 10, 23.5 Python, ROSM and true. Now I want to discard ROSM. So as you can see, the ROSM string is discarded from the set P. And now I don't have any ROSM string in this B set, right? So if I try to discard a string ROSM again, so if I try to discard it, as you can see, I didn't get any error. So this is safe from the key error. But if you try to remove an element which is not in the list using the remove function, we will get a key error. But with discard, we will not get any error. As you can see, we didn't get any key error here. Just if I print it again, it will normally be printed. If I try to discard an element that is 100, let's say. So 100 is not present in my set. So that is why, as I used discard, I didn't get any key error or any error. And then we also have a function called as pop. So pop function is used to remove any arbitrary element. So here arbitrary element means a random element or unpredictable element. So when I use this pop function, any random element can be removed from my set object. We wouldn't know which element we are removing. So if we call pop function on an empty set object, we'll get a key error. So here I have a set B, which consists of 5 unique values. So these are my values: true, awesome, Python, 23.45, 10. Now, first, I'm trying to pop the some random value. So I can use dot pop parenthesis. So if I pop, I'll get the element which is popped. Okay. So here true value is popped. So now if I print B, so as you can see, we only have awesome, Python 23.45 and 10. Initially we have true, it is popped now, and we have only these four values. Again, if I try one more pop, now awesome value is removed. That is, this value is also removed. And if I try one more pop, now Python is also removed. And then one more pop, it randomly removes 23.45. And if I do one more pop, now 10 is also removed. So as you can see here, first true is removed, and then Prosum is popped. So Prosum is in there, then Python is popped. So Python is in there, and 23.5 is popped, and then 10 is popped. So this works internally randomly only. And now if I print my set, we have an empty set. So in this empty set, if I want to pop any element, I'll get a key error, that is pop from an empty set. So we cannot pop from an empty set because it doesn't contain any element. So that is why we'll get a key error. So here if you see, we have a set A, and that consists of 10, 20, 30, 40, 50, 60, 70, 80, and then two strings that are Python and Java. And if I print it, so we have, so this is displayed randomly, right? In the same order, it is not displayed obviously. And first I'm trying to pop. So one pop. Now Java is popped. And then we'll pop one more element and 70 is popped. And one more pop. So here, as you can see, 40 is popped. And then I'll be popping one more. Then 10 is popped and removed. And then one more, 80 is popped. And one more, 50 is popped. So as you can see, after popping all these like 5 times to 6 times, we have left elements are 20, 60, Python and 30. Now let me pop one more element. So 60 Python, 30 are only remaining, 20 is popped out. And then one more 60 is popped out, and one more 30, sorry, Python string is popped out. And if I pop one more time, we'll get an empty string. Now on this empty set, if I try to pop, we will get a key error, which is pop from an empty set. We cannot pop elements from an empty set. And then here, so these are not the modification functions. So we are starting the comparison functions here. So what happens here is we have a function called as isDisjoint. So this function will let us know if two sets are disjoint or not. So disjoint means, so two sets are said to be disjoint if they have no common elements. So disjoint means they have no common elements. So if common elements are there in some pair of sets, so that means if you take some Venn diagrams, so common elements means intersections, right? If you have learned in your schooling, so the Venn diagrams are drawn this way. So first circle represents my set 1, let's say, and second circle will represent set 2. So if these both have common elements, that will be like this. So this is the common part of both the sets. And this is the intersection part. That's called intersection. So circles will overlap if the sets have common elements, circles will overlap. And if I do S1 dot is disjoint S2. Okay, so it will check if S1 is disjoint of S2. But here if you see S1 and S2 have common part. So that is the intersection part and circles are overlapping. So what will be the output is, it will be false. So basically how this is considered is, as you can see, I've done it here. So it will check if S1 is disjoint of the set S2. So in the parenthesis, what you'll give, you'll compare S1 and S2. So if they have common elements, there will be intersection part and circles will overlap. That is why it will be given as false. So S1 has common elements. That is why it is disjoint is false. Let's just firstly have some examples and then you'll have better idea. So S1 is equals to 10, 20, 30 and 40. And if you see S2, which is set 2, it has 10, 50 and 60. And S3 consists of all negative elements, that is 10, 20 and 30. Minus 10, minus 20, minus 30. So S1 consists of 40, 10, 20, 30, which is a set data type. And S2 consists of 10, 50, 60, which is also a set data type. And S3 will consist of the negative elements, that is minus 10, minus 20 and minus 30. So here, so basically disjoint means, so the circles don't have any common part, right? Disjoint. Joint means they're joining. Basically, if you see the English terms, joint means they're joining with each other, like they have some overlapping area. Disjoint means they don't overlap at all. So no common elements. So if there are common elements, so if common elements are present, circles will overlap. So that is why you'll get disjoint is disjoint value as false. So if you don't have any common elements, what will be happening? So the circles don't have any common part. So they don't overlap, right? So circles don't overlap. So that is why they are disjoint sets only. So when you do is disjoint, so S1 is disjoint of S2. That is S1 is disjoint of S2. So that will be true. As they don't have any common elements, that is true. As circles don't touch, they are disjoint. So the output will be true. But if they have common elements, so they will overlap. So that is why is disjoint will be false because it is not disjoint sets. So here the set 1. So let's compare set 1 and set 2 first. Okay. Set 1 here, it has 10, 20, 30, 40. And set 2 consists of 10, 50, 60. So if you see 10 is the common part in both of these sets. So when I try to draw Venn diagram of set 1 as set 2, 10 will be in the common part because 10 is in set 1 as well as set 2, right? So that is why 10 is in the common part. And the remaining elements in S1 are 20, 30, 40. And in S2, what are the remaining elements? 50 and 60. So basically S1 consists of 10, 20, 30, 40, and S2 consists of, fill this circle, 10, 50, 60. And S1 and S2 has a common part of 10. So as you can see here, there is a common part because the circles are overlapping and it consists of that value 10, right? So it consists of value 10 and it has common elements. So that is why if you perform S1 is disjoint of S2. Disjoint means the circles should be separated. They shouldn't have any. But here there is a common part. So is disjoint will be false. So if your elements or the sets have common elements, disjoint will be false. If they'll have no common part, then circles won't overlap and the output will be true. As you can see here, S1 is disjoint of S3. So here, if you see, S1 consists of 10, 20, 30, 40 and S3 consists of minus 10, minus 20, minus 30. So there is no common part, right? So common element is not there. So your set 1 will consist of 10, 20, 30, 40 and set 3 will consist of minus 10, minus 20, minus 30. So as you can see, there is no common part. So that is why they are disjoint sets. So is disjoint, S1 is disjoint of S3. So that will be true. So you can see here S1 is disjoint of S2 will be false because they have a common part. And S1 is disjoint of S3 is true because they don't have any common part and circles don't overlap. You can also check the is disjoint using in this way. So you can give a set with some values like 10, 20, 30 is disjoint of dot is disjoint is your parenthesis. This is your function, right? So inside of this function, you can give one more set. So here they have given one more set, which is 30, 40, 50, if you see this line. So here, the first set consists of the S1 set, let's say. Let's consider this as S1 and this as S2. So set 1 consists of 10, 20, 30 and set 2 consists of 30, 40, 50. So if you see here, the common part is 30, right? So when I draw the circles, so this is S1 and this is S2. So my common part consists of 30 and remaining elements in S1 are 10, 20 and remaining elements in S2 are 40, 50. So as these circles have a common part which is 30, so it has common elements. So is disjoint will be false. So they are not disjoint sets. So that is why it is disjoint is statement is false. And then moving on, we have one more example 10, 20, 30, 300, 400, 50. So if you see these both sets, S1 S consists of 10, 20, 30 and S2 consists of 300, 40, 50. So if you see there is no common part, no common part. So they don't overlap. So these are both disjoint sets. So when we give the set 1 which is 10, 20, 30, it is disjoint from the set 2 means. So that statement is true. So that is why this will be giving true. And one more thing here, set parenthesis means, so that is a empty set, right? So empty set, let's take in this way. So it doesn't contain any elements. So this is a empty set. So empty set doesn't have any elements. And then I have one more set. So I'm checking an empty set with one more empty set. So that set is this. So let's say this is the set 1. Here this set is the set 1. And this is the set 2, which I'm talking about. So this is set 2. So if you see here, these don't have any overlap. So there are no common elements, right? You need to check for the common elements when you are checking the is disjoint. So there are no elements only to check in this empty sets. So there is no overlap. That is why you will be getting is disjoint means true. And if you see here, so we have 10, 20, 30 set. So this is a set 1 and is disjoint set. It is an empty set. Let's say this is set 2. So in this 28th line code, so what happens is first your set 1 will consist of 10, 20, 30. But set 2, which is empty set, doesn't consist of any elements, right? So empty set doesn't contain any elements. So there are no common elements to check the overlap also. So there is no overlap of these both sets or circles. So that is why here it will be given as true only. So now let's check the outputs if there are correct or not with it. Okay. So when you want to know if two sets are disjoint or not, first you need to check their elements, common elements. So let's run this. So if you see here, set 1 that is 10, 20, 30 is disjoint of set 30, 40, 50. It is false because they have a common element that is 30. And then moving on, 10, 20, 30, 300, 40, 50. So this doesn't have any common part. So that is why it is true. And moving on, check 10, 20, 30 set with an empty set. So this will be true because the both sets, they don't have, so the empty set doesn't have any elements to check if it is having common elements with the set 1, right? So that is why they both are disjoint sets. And when it comes to both empty sets, so here also the same thing. We don't have any elements to check if there are common in both the sets or not. So that is why empty set is disjoint of one more empty set. That will be true as there is no overlap of circles here. So I request everyone to take a 1 minute break and have some water. Okay, everyone, let's continue with the topics. So now sets have a function which is called as is superset. So superset means a set A. Let's say a set A is said to be a superset of some set B if A consists of all the elements of B. So let's say B consists of 10 and 20. Okay. A will consist of 10, 20, 30, 40. So do you think A is the superset of B? Yes, it is the superset of B because the elements which are in B, that is 10 and 20, there are present in A also, 10 and 20. So that is why you can represent this Venn diagram as your B set here. It consists of 10, 20. And your A set is the outer set which consists of 30, 40. So all the elements of set B are inside of the set A. So all elements in set B consisted by the set A, which consists of 10, 20, 30, 40. So that is why your A is said to be the superset. And one more concept is here B is considered as a subset because the subset means a set is said to be a subset of one more set if all the elements of this set is inside of another set. The same way, if A consists of all elements of B, A is said to be superset. If all the elements of B are in A, so B here is said to be subset. So this is like a child and your superset is like a parent. So if elements of all of B is present in set A, so B is said to be subset and A is the superset here. So now we have a condition where we check if a set A is a superset of set B or not. So how we can check is, so this condition here is this. So basically, if all the elements of B are in A or all elements of B are equal to A, then A is the superset here. So what you need to check is, you should check if B is completely inside of A. It should contain all elements of B, right? A should contain all elements of B. Then only A will be superset and B will be subset. So here you need to check if all elements of B are in A. If you see here, you can use E superset using the syntax dot E superset of subset 2. So here we have a set 1 consists of 10, 20, 30, 40, 50. And set 2 consists of 10, 20, 30. So if you see, all the elements in set 2 are in all elements, like they are present totally in set 1. So if I draw Venn diagram, so this is set 1, let's say, and this is set 2. Okay. So set 2 consists of 10, 20, 30. So all these elements are already in set 1 and remaining elements are 40 and 50, right? So 40 will be here, let's say, outer of set 2. So as you can see, set 2 is totally inside of set 1. So that is why set 1 is the superset. So if you check here, S1 dot is superset of S2. So that will be true because all elements of S2 are present in S1. So if you do that, we will be getting, sorry, first you need to refresh the memory using assigning and then you need to do it. So S1 consists of 10, 20, 30, 40, 50 and S2 consists of 10, 20, 30. So all elements of S2 are present in the set S1. So that is why S1 is superset of S2 statement is true. So that is why we got the condition true. Now we'll check S1 and S3, okay? S1 consists of 10, 20, 30, 40, 50. And S3 consists of 10, 60, 70. If you see, the common part is only the 10. So when you try to draw the Venn diagram, so what will be here is S1 and S3, let's say. So common part is only the 10, right? So in the overlapping part, only 10 will be there. 10 is in both of these, but S3 consists of more elements like 60, 70. These 60, 70 are not present in S1. So S1 consists of only 20, 30, 40, 50 and 10 lastly. So all elements of S3 are not present in S1, right? So that is why S1 is not this superset of S3. So when you try to do S1 is superset of S3, that statement will be false. So that is why here output we will get as false. So only if the set 2's elements are completely present in set 1, then itself your set 1 is the superset. And then moving on, we have, if you see, this is example 10, 20, 30. So I'm comparing this set with an empty set. So this is an empty set. So here this is a edge case because empty set doesn't consist of any elements, right? So as there are no elements to check, automatically this condition will be satisfied. So that is why we'll be getting true. But theoretically speaking or logically, every set is a superset of empty set. So empty set, when you have an empty set, every other set which consists of elements or which doesn't consist of elements. So every other set is a superset of empty set. And also an empty set is a superset of one more empty set also. So itself, it is a superset. So if you see here, we have 10, 20, 30. So when I try to do this, is superset of an empty set or not, I'll be getting true. So this is because of the statement, every set is a superset of empty set. So as there are no elements to check in this with the superset element, so automatically your condition will be satisfied. So every set is a superset of empty set. And then moving on, we have a set which is empty set is superset of one more empty set or not. So they are checking that. So what happens here is, so here we have the set 1 or set A. It is an empty set. So this A, and set B is also an empty set. So both sets are empty sets, right? So does empty set contain all empty set, like all the elements of one more empty set? So they will consist because they have nothing, right? So both consist of nothing. So no element is there in both the sets. So it is considered as an empty set. It will consider all elements of one more empty set also because they have nothing. So the result will be true only. So logically, an empty set is a superset of itself. So what you need to remember is every set is a superset of empty set and empty set is a superset of itself. So these are the both edge cases. And then moving on, we need to find is subset. So we have a function. So this will tell if one set is a subset of another set or not. So when it is considered as subset is, as we have known, if one set, let's say B. So if B, all elements of B, if they are present in A, then B is the subset of A. Here B will be subset of A. So if you check here, S1 consists of 10, 20, 30, 40, 50 and S2 consists of 10, 20, 30. Let's say here, this is S1 and this is S2, okay? So S2 consists of 10, 20, 30 which are also present in S1. If you see, these are the common parts. So the remaining elements in S1 are 40 and 50. So as S2 elements 10, 20, 30 are all present in S1, so S2 is the subset of S1. So let's check that. S1 is subset of S2. So that first you need to run this and then you can go to this. So here S1 consists of 10, 20, 30, 40, 50. S2 consists of 10, 20, 30. So here I'm checking if S1 consists is a subset of S2, not in the reverse order. So here I'm checking if S1 is subset of S2. So what happens here is all the elements of S1 should be present in S2. Then only your S1 will be subset of S2, right? So if you see here, there is 10 and then 20 and then 30. But 40 and 50 are not present in S2, right? So that is why S1 is not the subset of S2. So that is why we got false here. And then moving on, they are checking if S1 is the subset of S3 or not. So that means you're checking these both. So all elements of S1 should be present in S3. Then only your S1 is the subset of S3. So 10 is present, but 20 isn't present, 30 isn't present, 40 is not present, and 50 is not present in S3. So that is why S1 is not the subset of S3. So when you try to do S1 is subset function of S3, you will get a false value. And then here we are checking in the next values if S2 is a subset of S1. So what happens is you are checking S2 with S1. So all elements of S2, that is 10, 20, 30, if they are present completely in S1, then S2 will be the subset of S1. So if you see here, S2 consists of 10. So that 10 is present in S1 and 20 is also present in S1 and 30 is also present in S1. So that is why all elements of S2 present in S1. That is why S2 is the subset of S1. So here if you do it, that's a true. And then you'll check S2 with S3. Only 10 is the common element, right? 20, 30 are not present in S3. So that is why S2 is not subset of S3. So when we run S2 is subset of S3, we'll get a false. And then moving on, we'll have the comparison of S3 if it is subset of S1 and S2 or not. So if you see the 10 part only is there. So in the S3 we have 10, 60, 70. Only 10 is present in S1 and S2 if you see. 60 and 70 are not present anywhere. So S3 is not subset of S1 and S2. So when I try to run these both, I'll be getting false because S3 is not subset of S1 and S3 is not subset of S2. So when I check is subset, we'll be getting false. And then moving on, we are checking if 10, 20, 30 set is subset of an empty set. So that will be false because to check also, empty set is something which doesn't have any elements, right? So you're checking if 10 is in this set, that is empty set. So that is not present. So if you check 20, 20 is also not present in empty set. 30 is also not present in empty set. So that is why is subset of empty set means it will be false. So this set is not subset of an empty set. And moving on, I'm checking if an empty set is subset of S1. So here empty set. So S1 consists of 10, 20, 30, 40 and 50. So is an empty set a subset of S1? So that is true because empty set is a subset of every set. So as we discussed before, every set is a superset of empty set, right? Every set is superset of empty set. So if you write in a reverse order, empty set is a subset of every set. So that is what we are applying here. So empty set is a subset of every set. Any set you have, an empty set will always be a subset of it. So here we have 10, 20, 30, 40. So empty set will be a subset of this as well. And it will be a subset of S2 as well. It will be subset of S3 as well. So that is why when I try to do this, empty set is subset of S1, that will be true. And also this empty set, I'm checking if it is subset of one more empty set. So in the same way, every empty set is subset of itself. So empty set is subset of itself. So all elements in empty set consists of all elements in one more empty set, right? So that is why an empty set is subset of every set. So that is why here we will be getting true. So if you see, an empty set is a subset of one more empty set. And then moving on, the same way, every set is a subset of itself. So that may be an empty set or that may be a non-empty set. Every set is a subset of itself. So basically, the final term is every set is subset of itself. So that may be an empty set. Empty set is a subset of itself. A non-empty set like S1 is subset of itself, that is S1. So basically here what it is S1 consists of 10, 20, 30, 40, 50, right? Let's take one more S1. You're checking, comparing with the S1 itself, right? So 10, 20, 30, 40, 50. So first you'll check 10. So 10 is present in the 10 in S1 is present in one more 10 in S1. So the 10 is present here and 20 you'll check. So that is also present here. 30 you'll check. That is also present. 40, 50 the same way. So every element of S1 consists of all the elements in S1, right? So because of that, S1 is a subset of S1 and S2 will be subset of S2 also. Same elements will be there, right? So all elements of here are present in one more. If you take S1, all present here. So all of these are present here. So that is why S1 is subset of itself. S2 will be subset of itself and S3 will be subset of itself. So every set is subset of itself and empty set is a subset of every set. So empty set will be present in every set. So that are the conclusions from this topic. And then moving on, we have a function called as union. So union means it will take all the unique elements from both the sets. So let's say I have a set S1 and then I have a set S2. So let's say they have common part. That is, there are common elements in both the sets. What they'll do is they will compare this and they'll only take the unique parts, that is here, which are unique elements only. They'll take and they'll merge, they'll take all the unique elements. Yeah. So here, let's, so S1 consists of 10, 20, 30, 40. And then moving on to S2, it consists of 40, 30, 50, 60, 70. So when I try to do S1 union S2, what it will do is, it will take only the unique elements inside of these both. So they'll merge both the circles fully. So let's say they have common part, that is here 30, 40 is the common part, right? So 30, 40, there are present two times. If you merge both these circles, that will be duplicates, right? So what they'll do is they'll take all the unique values 10, 20, 30, 40, 50, 60, 70. So what they'll do is they'll take all the values, they'll merge it. And as you know, set will only give you the unique values, right? They'll not give duplicates. So that is why when you do dot union, it will take all the, it'll take all the values firstly 10, 20, 30, 40, 40, 30, 50, 60, 70. And it will merge it, merge the both circles and it will give only the unique elements from that. So if you see here 10, 20, 30, 40, 50, 60, 70. So 30, 40 are not present two times, right? So they are taken only unique times. So only one time. Only unique elements it will give. And then duplicates are removed. So you can do in this way also, and you can also assign this union function to one more set S3 and then you can also print using that. So here these are the unique values in the both sets. So using unique union you can get this. So there is a shortcut to get the union. You can use a, a key which is called as vertical bar or pike key. So using that S1 vertical bar S2, this will give you the union of the S1 set and S2 set. So union means it will take all the values, it will merge the both sets and it will give the unique values only. So using the vertical bar also we will get unique values in the both sets. And then there is a function called as intersection. So what this intersection does is it will take only the common elements, only the overlapping part. So when I have a set 1 and let's say we have one more set S2. So if you see, when I'm taking S1 and S2, 30 and 40 are the common parts, right? So we should not draw them this way. How we should draw them is, so in this way, they have a common part. So common part consists of 30, 40, right? And the remaining elements in S1 are 10, 20. And remaining elements in S2 are 50, 60, 70. So common part consists of 30, 40 as there are the common elements in both the sets. So when you perform intersection, so how you can perform intersection is the first set name dot intersection of, in the parenthesis you should give the second set name. So now I'm comparing these both and I'm getting the common part only. So the common part is 30, 40, right? So I'll be getting 30, 40. I can also do it in one more way. So I'll do intersection and I'll assign it to S4, which is a new set, and the S4 can be printed, or you can do it directly. So first I'm taking S1 and then S2. Now I want common part from this S1 and S2, so I'll perform intersection. So intersection will give me the common part, which is 30, 40. So as you can see, as it is a set, they will be unordered. So this is jumbled, 30, 40 or 40, 30, the same thing. So this is the common part. You can use a shortcut using the key which is called as ampersand. So you can use this ampersand to perform the intersection also. So this is the easy way, and you can just use ampersand and get the common part. So moving on, we have a function called as difference. So what difference does is, it will, let's say I'm performing S1. So how I can perform it is S1 difference S2, let's say. So what this does is, this will remove elements of S2 which are present in S1. Totally it will remove and it will give the S1 value. So here, let me perform the code. So S1 consists of 10, 20, 30. And S2 consists of 40, 10 and 50. If you see, what it will do is, first it will check. In S2, there is a 40. It will check with S1. There is no 40, right? So it will ignore this. And if you take 10 in S2, I need to subtract this 10 if it is present in S1. So there is a 10 here. So this will be removed. And it will check next the 50, which is in the S2. If it is present in S1 or not, it will check. So as it is not present, this will be ignored. So it's same like a subtraction. So only when I do difference, so S1 dot difference of S2, so the S2 elements, if there are present in S1, so they will be removed. So it's same like removing the common parts. If I have 50 in the S1, then I'll remove that. So that way, this will be removed. But if I do, let's say S2 dot difference S1, let's say. So what happens here is, it will check if S1 elements are present in S2 and it will remove that elements in S2 and it will print S2. So if you see here, now what I'm doing is, I'm subtracting S1 elements from S2 elements. So first 10. So 10, as this 10 in S1 is present in S2, this will be removed. And 20. 20 is not present, so there is nothing to remove. So 30. 30 is also not present. So at the end, it will print the remaining elements in S2, that is 40 and 50. So if you see here, first we are performing S1 dot difference of S2. So S2 elements are removed from S1 and then it's printed. So as I have assigned this to S5, so S5 is the remaining elements on S1 after subtracting the S2 elements, which is 40, 10 and 50 from the S1 elements 10, 20, 30. So 10 is removed and the remaining elements, which are 10, 20, are printed. So if you see here, these are just comparison operators, right? So this will not affect the original sets. So if I perform this without any S5, let's say. So S1 dot difference S2 means this will only produce a new set without modifying the original ones. So when I do the dot difference function, it will produce a new set after removing the S2 elements in S1 and it will produce a new set. But the original sets, if you see here, the S1 is same as the original one. There is no change here. S2 also same. So the original sets won't be modified. A new set will be created which consists of the difference of this S1 and S2. So here also now I am giving S2 difference of S1. So S1 elements will be removed from S2 set and they are assigned to S6. That is a new set, right? So if I do this, what happens is S1 elements which are 10, 20, 30 will be removed or subtracted from S2 elements which are 10, 40, 50. So 10 is the present, right? So 10 will be removed and only 40, 50 are in the output when I perform S2 difference S1. So here you can see only 50 and 40 is given. If you print S1 and S2 again, they will be in their original states only. So this is a new set which consists of the difference when S2 dot difference of S1. So you can also perform shortcut of difference using the hyphen. So that is like a minus, right? So what I'm doing here is I'm subtracting the values of S2 from S1. So only the remaining S1 values will be printed. That is 20 and 30. And then moving on, you can also give S2 dot S1. So here S1 dot difference of S2 is equal to S1 minus S2. And then S2 dot difference of S1 is equal to S2 minus S1. So here I'll get only the remaining values which are 40 and 50. And then there are two more functions in the sets, guys. And then we'll learn about frozen set and we'll be done. So please be patient. So we have symmetric difference here. So what symmetric difference does is it will remove the common parts. So in the difference here, what it will do is using Venn diagrams, if I do it, so this is set 1 and S2, right? So here what happens is when I do S1 dot difference S2, so this will remove this whole S1 part, S2 part from S1, right? So only the remaining elements in S1 are printed. So if I do S2, so this is for this. So I'm removing whole S2 part, this circle. Totally I'm removing from S1. So only the unique elements in S1 are printed. So when I do S2 dot difference S1, what happens is this is S1 and this is S2, let's say. So all elements from S1, this circle totally it will be removed and only the S2 elements that are these, the shaded part will be printed. So this is the difference. But when it comes to symmetric difference, what happens is symmetric difference will remove the common elements and it will take the non-overlapping parts in both of that sets. So what it will do is if I have a set S1 and S2, this will remove the common part. So this will be removed and it will only print these non-overlapping parts only will be printed. So if you see here, let's take S1 equals to 10, 20, 30, 40. Okay, the common here and S2 is 40, 30. So common part will be 30 and 40, right? And remaining in S1 consists of 10, 10 and 20. Common part consists of 30 and 40. And S2 remaining is 50, 60, 70, right? So 50 will be here, 60 and 70. So what symmetric difference does this? So this will remove this part completely. So totally it will remove and it will print only this remaining overlapping parts. non-overlapping part, sorry. So it will print this part. Only these parts will be printed. The overlapping part, it will not be printed. So here what I'm doing is S1 consists of these, right? So here S1 dot symmetric difference of S2. So the common parts which are 30, 40 will be removed and the remaining elements totally will be printed. So here I performed that and I'm assigning that symmetric difference to S7, right? So as you can see here, first we need to run this neatly and then I'll get the value of S7. So here the common part is 30, 40, right? So the remaining elements only will be printed. Common part will not be printed. 10, 20, 50, 60, 70. So 10, 20, 50, 60, 70. These are printed in a shuffled order. So that is the symmetric difference here. So even if I do S2 dot symmetric difference of S1 or S1 dot symmetric difference of S2, you'll get the same value because you are just removing the common part and you are printing the non-common part or the non-overlapping part. So if I print this as well, the same values which are just shuffled here. 10, 20, 50, 60, 70. 10, 20, 50, 60, 70 will be printed. So the shortcut for this is I can use a symbol which is called as a circumflex or caret. So this symbol is called a caret or circumflex. So you can use this directly to do symmetric difference of two sets, S1 and S2. So when I do this, I'll get the same value with how I got with symmetric difference only, I'll get the same values. So this is that. So here I have two sets which consists of first set consists of Ram, Lakshman and Raj, let's say. Okay. And one more set consists of, which is a CP, consists of Sachin, Kohli and Ram. So when I have these two sets, if I want both CP and TP sets completely, which are unique elements, if I want from both the sets completely, I can use union function and I'll get the union of the both sets. If I want only the common part in both of these, I can just use dot intersection or I can use, yeah. Okay, I've not changed here. So common CPTP. So when I want the common part in both of these sets, what I can use is I can use an intersection function and I can get the common part. So if you see, Ram is the only common element in both of these sets. So that is why I got only Ram. And I can also perform intersection using the ampersand and Ram is the common part. If I want difference, only TP I want. So from TP I want to subtract CP. So TP dot difference CP will give only the TP values. So only the first set values. Removing the common part and S2 part totally. So Lakshman and Raj will be the. So if I do that, so here we have Ram and TP. So this is TP and this is CP. Here we have Lakshman and Raj and this is Sachin and Kohli and Ram, right? So Ram is the only common part. So if you see here, when I want only TP, that is only TP without the common part and this part. So Lakshman and Raj are the values in only TP. So that is what I got. And then if I want only CP values, so I'll be doing CP dot difference TP. So TP values will be removed from CP. So I'll get only Sachin and Kohli. So only this part without the common part and S1 part. This part I'll get Sachin and Kohli. And then moving on, I can also get difference using the minus, right? So only TP is TP minus CP. Only CP is CP minus TP. And if I want except the common part, that is the symmetric difference I can do. I'll be getting Lakshman, Raj, Sachin and Kohli. So to get the values except the common part, I can use symmetric difference. So when I run this, I'll be getting Lakshman, Raj, Sachin, Kohli in a jumbled order. And I can also use this caret key or the circumflex key to get the symmetric difference. And then lastly, we have this function update. So when you want update one set with another set values, you can use this. So using the dot update parenthesis, you can use it. So here you can see S1 consists of 10, 20 and S2 consists of Python and data science. So when you want to update S1 using the elements of S2, you can use S1 dot update S2. So what happens here is S1 will be updated with the elements of S2, but S2 won't be changed. Only the S1 which is stored in different location, it is updated with the values of S2. So there will be 4, but S2 is not modified. And we have one more S1, and inside of this I want to update with the string 10, 30, 40 Python. But here you can see that there are duplicates, right? So only unique values will be printed. Even if you update with duplicates, only unique values will be printed like this: 10, 20, 30 and 40. So moving on now, this is the last topic for today, that is frozen sets. So frozen sets are nothing but they are just like the frozen version of sets. So this is a predefined class and it is used to store multiple values either of same type, different type and both types. And these also store only the unique values. They will not store duplicates. So frozen sets also won't have the duplicate values same like sets. And there is no certain notation for frozen sets. You can just convert any other type like list, tuple or set elements into frozen set using the frozen set function. And this frozen set does not maintain the insertion order because, as you know, these sets will use hashing, right? So that is why it will not maintain insertion order. And the types of frozen sets are empty frozen set, which does not consist of any elements, and non-empty frozen set, which consists of elements and size is greater than 0. So this also frozen set can also not perform indexing and slicing because there is no order. So due to no order, indexing will not be done and slicing also cannot be done. So the main difference between set and frozen set is, so set is a mutable one and frozen set is immutable. So you cannot modify the elements once they are created. So moving on to the coding part. So frozen set here. First, we can convert list tuple or set to frozen set using the frozen set function, right? So here I have a list which consists of duplicates and 10, 20. So here list 1 L1 is used with square brackets and created. So this is my list L1. Now what I can do is I can give here frozen set function I can use. So inside of this frozen set parenthesis I'll give L1. So this L1 list will be converted into frozen set, that is FS1. So when I run this, so as you can see, firstly it is a list, but now it is converted into frozen set using the frozen set function. So the class frozen set is given. You can also do this with tuple. So here I have a tuple value which is immutable and I'm converting this T1 tuple into frozen set using the frozen set function. So as you can see here, firstly it is a tuple value. Now it is converted into a frozen set. So as you know, the sets only have unique values, right? Even if you give duplicates in your list and tuple, it will give only the unique values in a frozen set. And then we have a set S1. So firstly, it is a set data type with values 10, 20, 30, 40, which are unique. Now I'm converting this into frozen set using the frozen set function. So this is a frozen set which is converted from a set and consists of 10, 20, 30, 40. So here I have a list. So this list consists of an inner list, right? So as you know, if I try to convert this frozen set, this list into a frozen set, what will happen is that will be like frozen set, a set value, and there will be 10, and then the inner list. So basically, when we do the same thing in a tuple, inside of tuple, this list value, the elements inside of list, like if I convert this list into a tuple right now, so as that will be converted, that will be like this, right? Tuple value. So inner list, they can modify 20 and 30, right? So that is why as list is a mutable data type, it cannot be an element of frozen set. So when I want to convert this, so this innerly, this is an element. So this element is a list. So list is mutable. That is why it cannot be element of frozen set, because frozen set is immutable, right? You cannot change the element. So when that element is a list which is mutable, so that cannot happen. So here I'm trying to give a list which consists of inner list. So here this list is the element, right? So now I'm converting this into frozen set. So as you can see, I got a type error, unhashable type. So list. So in frozen sets, we use hashing mechanism, right? So due to that, only hashable elements or immutable elements can be elements of frozen set or set also. So that is why as list is a mutable type, it is not hashable, and that is why that cannot be element of a set or frozen set. So here in the we have one more set which consists of strings and int values. So that can be a frozen set. So directly I'm converting a set. So here curly braces, I have elements. So this set I'm converting into frozen set fs4. And here we can create an empty frozen set using just the frozen set function. So this is a empty frozen set. So the length is 0, right? So it doesn't contain any elements. And then moving on, I have a set. I'm converting this set to 10, 20, 30, 40 unique elements into frozen set F1, FS1. So if I try to print FS1 equals to 0, so we'll get a type error, that is frozen set object is not scriptable. So that means as it does not have any insertion order, right? Set and frozen set will not have any insertion order. So that is why you cannot give indexing. So in frozen set also, there will not be performing indexing or slicing. So that is why here we got a type error. And then if I want to assign some value at the position 0, so that is also will get a type error because item assignment is not possible. So this item assignment or modification of values is not possible because there is no insertion order. So also it is immutable. So as it is immutable, we cannot add elements also. So in this way, frozen sets will work. So today we have covered set category data types and what is set and why duplicates are not allowed and why there is no insertion order and why indexing or slicing is not possible with sets. So that we have learned today. And we also learned what is a frozen set and the difference between set and frozen set. So set is mutable and frozen set is immutable, and both will work with the hashing mechanism. So that is how it works. So list is for ordered collection and set is for unique collection. So it will not only have unique elements, and frozen set is for fixed unique elements. So unique elements and also they are not modifiable. So they have fixed unique collection. And the practice problems for today are this. So please take a screenshot and note them. Tomorrow we'll be learning about the remaining data types, which is dictionary data type and none type. So that's it for today, guys. Please note these questions. And if you have any questions, put it in the chat box. And we have the Python for AI 2026 playlist in our channel. You can visit the previous lives and the videos, and you can revise them or listen to them. And if you like the videos, please hit the like button and subscribe to our channel. So for now, please take a screenshot or note these questions down. And if you have any questions, please put it in the chat box. So we'll meet again tomorrow. So that's it.